Welcome to the Rich Report, a podcast with news and information on the world of big data. Today, my guest is from ALTISCALE. They're called the Hadoop Cloud Company, and we have the CEO and co-founder of the company, Raymie Stata. Welcome to the show today.
Thanks. Great to be here.
Well, thanks for coming on, Raymie. You know, I was looking at your background. You certainly have a long history in data analysis and Hadoop with work at places like Yahoo. So first of all, Raymie, let me ask you, how did this all get started?
Thanks, Rich. I like to start the story of ALTISCALE by going back to the mid-90s when I began a 15-year stint in the world of algorithmic web search, starting at AltaVista and ending at Yahoo. What I saw over those 15 years is how Hadoop and its predecessors, and more importantly, the data science we ran on top of those systems, how that transformed algorithmic web search and then sponsored search, digital advertising, and media, and driven by some really exciting algorithms. And as I look forward, I can see that a lot of what we learned is going to be relevant to a lot of other industries. When you look at all the data that's becoming available, this data will create huge opportunities to drive business value in almost all industry sectors. But to take advantage of that data, you need to have a well-run data infrastructure. Today, Hadoop is the de facto data infrastructure. So you effectively need to have a well-run Hadoop infrastructure, a place where you can land and manage the data, transform it in flexible ways, explore it, and apply advanced algorithms to it. And that's the kind of infrastructure we want to provide. As you can tell, we're excited about the possibilities that these data make possible, and we want to provide a platform for our customers to basically take advantage of that data, to focus on getting value out of it, and not get distracted by the complexities of the underlying infrastructure itself. So that's kind of the background and really the mission of the company. To get a little bit into the product itself, again, it's best understood in the context of the history of many of the folks here at the company. Many of us come from Yahoo or from Google. We've had experience either with Hadoop directly or with systems very similar to Hadoop inside those large internet companies. And inside those companies, the way it works is that there's a team, a central team that runs a large service that everybody can use. And there's a nice division of labor between the people who are running that service and the people who use it, the developers and the data scientists who want to find value in the data. And that team, first of all, is responsible for delivering a very reliable service, a scalable service that can keep pace with the growth of the company. But less obviously, they're also responsible for providing support, for helping the people who use the service to get their job done effectively. When I left Yahoo and I looked around at Hadoop usage in particular, what I saw of subscale and really subpar Hadoop environments, environments of 5 nodes or 20 nodes, environments where there was kind of like a quarter of a person looking after it and running it, environments where the people running on top of the service had no support. When anything went wrong, they were their own first kind of line of defense in terms of figuring out what went wrong, even if that was at the Hadoop level. And as a result of that, people just aren't as effective at getting the most out of this infrastructure and their investment in it, and getting the most out of their data, because the infelicities in the infrastructure itself are just getting in the way. So what we've done at ALTISCALE is we've built the world's first purpose-built Hadoop Cloud with a vision of bringing the type of service to the general market that folks inside those large internet companies have. What are the 3 legs of our product? First and foremost, it's what we call infinite Hadoop. We want our users to feel like they have access to an effectively infinite Hadoop infrastructure. What that means, first and foremost, is they have Hadoop dial tone. Hadoop is always on. It's always at their fingertips. There's no moving stuff in and out. There's no creating or taking down clusters. And it's very reliable. You can count on it being up, and you can count on it being able to get your jobs all the way through to the end. In addition to that, it's automatically elastic. You don't have to worry about nodes. You don't have to ask yourself, hey, is there enough nodes to run this job? Are there too many nodes? Am I wasting money right now? Instead, you just store stuff, you run jobs, and we take care of making sure there's enough capacity available to you. So that's leg number one, is this effectively infinite Hadoop environment where users can just come and access the system. But as I mentioned, it's important for users to have support. It's not easy to use Hadoop. And it turns out that to run Hadoop well, you also have to monitor not just the infrastructure underneath it and Hadoop itself, but the jobs running inside of it. You have to make sure that those jobs are healthy. Because we monitor the jobs, we're able to provide proactive support to our users. So if it looks like a job is going to fail, we can often tell our users that maybe a few hours before it actually fails, which saves them a lot of time. And even if a job makes it all the way through, there are certain metrics we can look at that indicate that the job is not well formulated, and we can give tuning tips back to the customer so that the job will run a lot faster next time. So those are some of the proactive elements of our help desk. But we are also available to answer questions around why something is failing, how to get a certain library to work effectively. So we do provide a lot of help using Hadoop. Now, we don't write the business logic. We don't do the data science. Our customers, that's their job. But using Hadoop can be tricky, and we're here to make sure that they're as effective as they can be. And finally, the Hadoop ecosystem is evolving very quickly. And to get the most out of your investment in Hadoop, you need to keep pace with all the change that's happening. Yarn in particular is introducing a whole new generation of computing paradigms beyond basic MapReduce. And so there's a lot of excitement and there's a lot of new capabilities on the horizon for users of Hadoop. But to take advantage of that, again, you need to stay current. And that's another thing that's important to our product. First and foremost, we keep our own infrastructure up to date. And we keep tabs of what's happening in the community and what's ready to go and what's still being cooked. And we surface that up through our product. But we also provide a lot of communication and a lot of tools and hand-holding to help our customers through those migrations, because staying current does take some effort. So an effectively infinite Hadoop cluster with a help desk, with proactive job monitoring that stays current with the latest innovations of Hadoop. That's what we mean when we say a purpose-built Hadoop cloud. Everything we do, our infrastructure, our team, our business, our software stack, everything is optimized around Hadoop, so we can provide our customers with the world's best Hadoop environment they could get, whether they did it on their own or whether they went to some other Hadoop as a service. The benefits to our customers are reasonably obvious, and really it nets down to one thing. Our customers can focus on their applications, on their data, and getting the most out of that data, and they don't have to worry about Hadoop itself. And in fact, we can help them be very effective at using Hadoop. So that's the ALTISCALE Data Cloud. There are alternative ways to get Hadoop, of course. Let's walk through a few of those. So, the classic way is to build your own Hadoop cluster on-premise. You can do it on your own. We call that DIY Hadoop. Or you could get any number of distribution partners to help you get that going. The challenge there, of course, is that first, there's a lot of capital expense there. You need to buy machines. You need a lot of expertise, which is expensive and takes time to grow. In addition to that, there's this issue of how big is your cluster. If you size your cluster to your biggest job, then it's going to be idle most of the time, and that's not going to be cost effective. But if you size your cluster for the average job, then when those big jobs come in, they become really disruptive. They push everything out. They take a lot of time to run. And therefore you can't really do too many big jobs. So elasticity in the context of Hadoop is actually quite valuable. It's very important, and you really don't get that in an on-prem solution unless you operate at the scale of a Google or these ginormous companies. So that's Hadoop on-premise. There's a number of models emerging around providing Hadoop as a service. One model is to get a managed Hadoop cluster, where essentially a outsourced partner will run Hadoop for you on dedicated infrastructure. It might be dedicated physical machines, very often it is, could be virtual machines. That solution helps with the expertise. It can help with the capital expense. A lot of times these people will allow you to pay for that underlying infrastructure on the go. But also, typically you sign up for, again, a fixed number of nodes, and so you have issues with elasticity. And also, the current vendors don't really provide the level of help desk support as I defined it earlier. And so they don't give you that. And finally, they're actually fairly expensive. So what a lot of people do when they're looking to get Hadoop as a service is they will go to an infrastructure as a service company, for example, Amazon being the most famous, but there's Rackspace, Joyent, and GoGrid. There's a lot of infrastructure service companies that are offering a Hadoop package. What these companies do is they package up Hadoop in a very nice way so that you can create a Hadoop cluster on some VMs pretty quickly. But once that Hadoop cluster is up, again, you're on your own in terms of operating Hadoop. If the name node goes into safe mode, if the resource manager gets confused, you're on your own. And in addition to that, not only now do you have to operate Hadoop, but you have to understand its interactions with the underlying infrastructure as a service. So there's in some ways, a compounding of the expertise that you need. In contrast, we provide you with Hadoop itself operating, and if the name node goes into safe mode, that's our problem. If jobs get stuck because of something in the resource manager, we're monitoring that. We see that, and we get in there, and a lot of times we can fix it without you even realizing that it happened. So our definition of Hadoop as a service is actually quite different, and we define it at a much higher level than folks who offer Hadoop on infrastructure as a service. Now, that's all very abstract. Let's take a look at what this means in practice. So what we have here is a diagram depicting the experience of a customer of ours who started out at Amazon on EMR and moved to us. And you can see how long their job took when they were at Amazon and what happened when they moved to ALTISCALE. And starting on the line for Amazon, let me say a little bit about the job. This is a complex data pipeline. It involves over 20 steps. The inputs are tens of terabytes. It was taking weeks to run. But it was doing some very sophisticated analysis. So it was a great big data application. This is true big data. If you look at the bar chart here, what the blue is time spent actually doing MapReduce work. So that's the actual work. In the darker gray, what you see is overhead. Data was getting moved back and forth between S3 and EMR clusters. And again, because the pipeline was so long and complicated, it made a lot of sense to checkpoint results all along the way. So if something went wrong, you didn't have to start from the beginning. You could start from one of these checkpoints. But to checkpoint in the context of EMR, you need to go to S3. So there's a lot of overhead there. But then there's the larger, lighter gray. What is that? Well, we called that debugging, and that's actually not really a great label for it. That is time spent, firstly, getting clusters going, right? So this is a big data job, so they needed clusters of hundreds of nodes, sometimes 500 nodes. So there were large clusters that needed to get going with EMR, and that takes time. Not only does it take time to get one going, but it can be, if you're going for spot instances and so forth, it can be very error prone, right? You just don't get the instances, or the cluster kind of gets wedged, and you have to restart the whole process. So there was a lot of time getting clusters going, and then this was a very demanding workload. And so it turns out that EMR was failing, reasonably often. And so there's a lot of jobs that failed and had to get restarted. And again, these are big jobs. They would take hours at a time to run. So if 4 hours into a 5-hour job, the job fails and you have to restart, you can understand how that starts to accumulate and add a lot of time. So that's what was happening at EMR. And you can see when they moved to ALTISCALE, the time went down. You can see that there's less blue, which means that indeed on the pure Hadoop side of things, it went faster because we have that purpose-built infrastructure that is optimized around Hadoop. And a lot of people ask about that. A lot of people want to know how much faster is it? How much faster is it? But the reason why I like this diagram is it points out that the improvement in speed on the infrastructure is really not the big story here. The big story here is having an always-on HDFS, so you're not having to move data back and forth, into some other storage system. Having a more robust, more reliable implementation of Hadoop that is capable of handling the very complex, demanding jobs that this customer had. And also having that help desk. There were some jobs that were formulated in less than optimal ways, and when we saw those failing, we looked at them a little bit and said, hey, if you only did things this way, it would fail less often. And it's all those intangibles that really made the big difference when it came to reducing this pipeline from weeks to days. Now, what you can see on the third line is that after running this application for a little while, our monitoring did indicate a few other places where they could go in and optimize their queries, and we were able to bring down the MapReduce even further. So more benefit from that help desk. Now people ask, hey, do we see this type of pattern a lot? And the answer is actually yes, we do. In terms of what goes into what we've labeled debugging here, what is it that's chewing up time? It depends on the customers. Again, customers with very sophisticated, challenging algorithms do tend to see a lot of failures, and we can help there. In other cases, Hadoop is fairly flexible in terms of how do you organize the data in how many files, what's the number of files, what kind of compression do you use? Do you have indexing on the compression? How you manage the data in HDFS can make a huge difference in your job performance. And again, through very simple monitoring, we can very quickly help people understand where some simple changes in how they organize their data can make a huge difference in performance. And these are not naive customers. These are customers, as you can tell. I mean, this is a 20-stage pipeline that read tens of terabytes of data. These are sophisticated Hadoop users, but the fact of the matter is that when you're in a hurry, when you're trying to build an application quickly to deliver business value, you'll always leave something on the table to be made better. So that's a great anecdote that demonstrates how being effective at Hadoop, at how using it well is really important to getting the most out of it and to being more cost effective.
So I mentioned auto-elasticity earlier. What does that look like in the real world? Well, what we have here are some graphs of usage of our product by real customers. Along the top, there is usage of the compute side, of yarn containers, to be specific. Along the bottom is usage of storage in HDFS. Each of the bars in these charts represents the usage within a day, and the darker lines is a 7-day rolling average of that. On the storage side, what's kind of interesting is you'll see a lighter and a darker gray bar. The darker gray is the average through the day, and the lighter gray is the peak on that day. The overall story here is to just reinforce what I said earlier, that Hadoop, both in storage and especially in compute, is a very bursty workload. There's a lot of spikes to it. So being in an environment where you just don't have to worry about this, you don't have to plan, hey, how many nodes am I going to need for today? but rather have an underlying system that takes advantage of that or takes care of that for you, brings a lot of value in the context of Hadoop.
So let me ask you a question here, Raymie, just to jump in. In your experience, do people tend to over provision because of this or under provision?
People tend to under provision because they're trying to save money, um, and the direct cost of a larger cluster is often more obvious to them than the indirect cost of a data scientist spending 2 to 5 more days to get something done. Um, and I see that a lot, and it's a kind of a shame because you go hire these really talented people who just want to go fast, and they end up kind of stumbling because they're on undersized, undersupported infrastructure.
And are they at a loss to, make it better?
The data scientists,
Yeah,
well,
yeah.
I will say they're an intrepid bunch. I mean, in some sense, they kind of treat the infrastructure they're given as a bit of as written in stone, certainly in terms of its capacity, and then and they view it as their job to make the most of it, um, and they don't often view themselves as empowered to go in and say, hey, you should be spending more money on infrastructure so I can go faster. So I find, by the way, on the HDFS side, it is interesting to see how much that does peak up sometimes, and what happens there. Again, it gets back to data scientists doing work, and they'll try to do something in 2 or 3 different ways, and they want to compare the result, the outputs of doing things in different ways, and that induces a lot of intermediate storage. So having an elastic HDFS store, that doesn't have an arbitrary cap on it, brings a lot of value to them. I'd like to tell a little bit of the story on the upper left-hand corner, because what you see there isn't a singular peak like you see on the right-hand side where there was a really busy day, but rather kind of a sustained peak over a period of a couple of weeks. What was happening there was a customer of ours, they had a practice of kind of remodeling something once a week. But when they were remodeling it, they did so by running, say, 2 or 3 trials. And after using they switched from another environment over to us. And after using us for a while, they kind of realized, boy, why should we stop with 2 or 3? Let's do 100. And so they kind of had this marathon session of just running and running and running kind of a whole bunch of different models, testing all kinds of different combinations of parameters. And they were able to do that because they had infrastructure that could just absorb more use. And that was a very successful exercise for them. So that is auto-elasticity in practice. That's a good segue into how we charge for our service, which is different from other Hadoop as a service companies. We are the Hadoop Cloud, so we want to charge for Hadoop in a cloud-like model. We have on our slide here the no nodes icon. We don't think our users should be thinking about nodes. They shouldn't be worrying about if they've got enough nodes in their cluster or too many nodes, nor should they be thinking about the cost of nodes and how that translates into Hadoop usage. So what we do is charge for Hadoop-specific units. So for example, we charge for yarn task minutes. That's how you get compute done in Hadoop, so that's what we charge for. Similarly, we charge for HDFS terabyte minutes. And for people who know the difference, these are cooked or replicated HDFS terabytes. And what a terabyte minute means, so let's say that you've had a 10 terabyte month. That could mean that you had exactly 10 terabytes all month long, but it could also mean that you had 20 terabytes at the start of the month and no terabytes at the end of the month. And to us, that's still a 10 terabyte month. For HDFS, that is absolutely unique. People don't charge for HDFS in that cloud-like manner, but that's how we charge for HDFS. We also have a data transfer allowance that allows people to get data in and out of our cluster. No one has really kind of hit the limits there. So that's kind of bundled into our product and not a separate charge. Now, what makes our plan unique, beyond the fact that we charge for Hadoop units rather than some underlying infrastructure, is that we package it together in monthly plans so that you can predict what you're going to pay. One of the frustrations of the cloud model, one of the frustrations of pay-as-you-go, is it becomes very unpredictable, and you can have months where you run, way over. So we introduce or borrow from the world of cell phone plans the concept of rollover minutes, right? You sign up for a monthly plan, and you will only get charged. We guarantee you for what you've signed up for. If you go over in a month, that's okay. As long as hopefully in the next month you'll be under. And so we smooth that out, which is very beneficial for our customers, especially when it comes to financial planning. Obviously, if you're consistently over, then we will come back and say, hey, maybe it's time for a bigger plan. If you're consistently under, you can get a smaller plan. So you do ultimately pay for what you use, but we smooth that out so that there's no surprises, and people can plan and budget appropriately. So that is our pricing plan. So we've been in a closed beta program for about 3 quarters. We have about 10 customers at this point. It's probably not surprising that a lot of those are digital media companies and digital advertising companies, because that's where Hadoop, and especially Hadoop as a service, has had the most traction. These are fairly large installations, tens of terabytes to a few hundreds of terabytes. And we have one customer, actually now it turns out 2 customers, that are targeting getting to a petabyte by the end of the year. People are using us for mission critical applications. We have customers where if we're down for a few hours, that's like a big, big problem for the business. And so we won't be down. And it's satisfying that they trust that we won't be down, and they've put that level of confidence in what we can do. So that's the ALTISCALE story. We provide an always-on, infinite, up-to-date, reliable Hadoop solution with a proactive help desk, which keeps the users of Hadoop, your data scientists and your developers, maximally effective at getting their work done. And we implement that on a purpose-built infrastructure by a team that is fanatically focused on Hadoop. We are targeting people who are either using Hadoop and want to get to that next level, or people who know they want to use Hadoop and they want to move super fast. And the core business value that we deliver to our customers is that we allow them to just focus on finding the value in their data assets and not get distracted with the complexities of Hadoop. And more than that, really help them be maximally effective at getting the most out of Hadoop and out of their data.
Well, thanks for that, Raymie. This has been very interesting. I come from the HPC side, so first question comes from that. In my experience, they've had trouble moving to the cloud because moving data across the network is painful at best and nearly impossible when we're talking about petabytes, right? It just takes too long to get it done. What do you have to help customers, or with your betas? Have you moved to do they send you disks, or how are you getting it done?
Well, first of all, in the context of, I think, most quote-unquote big data applications in the commercial world, the most valuable data is the recent data, right? And the most important data transfer problem is getting new data in. And so when we engage in customers, we really focus on getting some recent data in and getting the data flows in place for new data. And at that point, you're not talking about petabytes. And by focusing on that, we can start to deliver a lot of business value very early on, and then come back to the issue of, okay, great, we love your environment. Now, what do we do about the archival data? And in the case of the archival data, at the end of the day, when it's more than somewhere between 30 to 50 terabytes, the most effective way to move it is through disks. And what we've done in a number of occasions is actually we have a whole stock of self-encrypting drives. Um, we send those out to customers. They load them up. They send them back to us. We copy the data off, and then we tell the drive to throw away the key. And the data is also kind of encrypted in transit. So if the drive happens to get lost, the data is safe.
What about like Hadoop is a framework and you build all this stuff on like pig and all this kind of thing. Are you able to accommodate that, or does that come back to the customer?
As far as open source components are concerned, we're fully tricked out, right? We've got Pig, we've got Hive, we've got Cascading, we've got Spark on Yarn, which has been a lot of fun. We've got Mahout and MLlib. So we have brought a lot of those open source components into our solution. So when you come to us, you get a fully tricked out Hadoop environment. In addition to that, we do have customers who have, say, a Revolution Analytics license for R, for the enterprise R, or a MATLAB license. And those systems have Hadoop integrations, and the customer pays for the license, but then we help them get that integrated into our solution. And because we're an open source, it's open source Hadoop deployed in a very standard way in terms of how it interfaces with the rest of the world. It's quite easy to get those proprietary solutions integrated into our environment as well. So whether you want a commercial solution or an open source solution, we actually provide a lot there.
Okay. And then in terms of the implementation on your side, are you running on AWS, or do you have your own data center?
Nope. When we say purpose built, we mean purpose built from the cement, all the way up to the organ system. So we are in our own co-location facilities. We do have direct connect into Amazon. Even though obviously we're competitive with EMR, with Elastic MapReduce, Amazon is an amazing infrastructure and an amazing environment to do a lot of different things. We don't compete with 99% of what Amazon does. So we really view them as complementary to what we do. So we have Amazon Direct Connect, which makes it easy to move data back and forth between our environment and Amazon. We do, though, have machine configurations, operating system configurations, network configurations, Java configurations, Hadoop configurations. Everything is optimized around an awesome Hadoop experience.
With Hadoop's reputation as being difficult to administer, it sounds like you're not just delivering a Hadoop dial tone. You're delivering a Ferrari Hadoop solution with a help desk that it might have taken me. I might have needed 6 guys to get it to do that, if I could even find them.
So yeah, I think that's a great way to put it. And I unfortunately, a lot of people don't understand the intangibles that we bring to the table in terms of all of that support and that Ferrari of an engine underneath. And as I indicated earlier, the developers and data scientists are intrepid people who will make do with what they're given. But that's folks who can do a lot more for the company if they're put in a better environment. So kind of putting them into that Ferrari and having the crew pit team, if you will, guiding them, around the track, will really help companies get a lot more out of them and to run a lot faster in terms of leveraging the value in their data.
Yeah, and at the same time, you're helping the financial side. Those guys hate surprises. Like, it's like getting a cell phone bill for $500. You freak out, right? And it sounds like you're able to take that intangible out, so they can do real financial planning.
Yeah, I mean, so my CFO who has had experience in other companies with Amazon bills, says that I should stop calling on the tech teams and start calling on the finance teams in terms of selling our product.
Yeah. You're stepping in to provide something much more packaged and reliable in terms of financials that has a value proposition that You could win just based on that. I agree. So Raymie, I want to wrap up here. The one point I wanted to ask you about, because coming from HPC, is resource scheduling and doing that efficiently. And is that something that your team really focused on? Because it's huge in HPC, because we have these huge compute resources, and if you don't keep them busy, you're really wasting lots of money every second. And I wanted to ask you about that.
That's a great question. And if you look at the kind of the 5-year tech plan for the company, that kind of floats to the top as like the awesomely cool problem that we can work on that brings a lot of value. But the way I view it, and the way I kind of actually want to jump into that problem as problem number one, is we have to earn our way into that, right? We have to have an awesome solution for customers, where in some sense we have a success disaster, right? We have so many people using this that it becomes important for us to really start optimizing the usage of tens to hundreds of millions of dollars of equipment, right? We haven't scaled up there yet, so we're really focused right now on how do we make this a great experience for the users. How do we make our users as productive as possible? And if right now the resource allocation is a little inefficient, that's okay. But you're absolutely right that once we hit that critical mass, we've got a lot of really fun work ahead of us in terms of that resource scheduling and allocation, and doing that specifically in the context of Yarn.
Yep.
And being driven from real world data in terms of, well, what are our customers doing, and how can we schedule this is going to be a lot of fun for us technically.
Well, great. Well, Raymie, I really want to thank you for coming on the show today. This has been fascinating, and I'm looking forward to hearing more from you guys. So thanks for coming on the show.
Great. Thanks for having us. Talk to you soon.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on the world of big data.